Hello again, everybody. It's Mr. Garrett again, and we're going to go through 4 different examples here where we factor cubic polynomials by grouping. Again, we've talked about sum and difference of cubes. The other thing that we can have is if there's 4 terms, we can try and factor by grouping. If we can't factor by grouping, then we're going to have to go to some other measures of trying to solve polynomial equations through synthetic division and things like that. But we'll get to that a little bit later on. So when we start to factor by grouping, we want to look at what we're examining here in terms of the polynomials. So this polynomial is x to the third plus x squared plus x plus 1. And if I look at grouping these first 2 terms in the last 2 terms, I can see what's common in these 2. And when I look to see what's common in these 2, I see an x squared. Whoops. I see an x squared common in both terms. When I take that out, I'm left with x plus 1. When I look at these second terms, I'm like, well, x and 1, but really 1 is common in both terms as well. So I say, all right, I'm going to take a 1 out, and I'm going to be left with x plus 1. Now, the key to grouping is making sure that what you have in these parentheses here and here is exactly the same. In this case, I have x plus 1 and x plus 1, so that is exactly the same. What I'm going to do then is looking at this big term, I'm going to pull out an x plus 1. Same thing here. There's an x plus 1 here. I pull it out. And when I have what I have left over is x squared plus 1, and that's going to be my other part, x squared plus 1. Now, if I can factor this or this any further, I would, but right now I can't. I have a sum of perfect squares, but that's not really a formula that we've talked about, and then we have x plus 1, which is a linear factor, and so that's our final factored form. All right, as we look at the next one, we have n to the third plus 5n squared minus 9n minus 45. Well, when I look at these first 2 terms, I see n cubed and 5n cubed, and or 5n squared. So I'm going to take an n squared out, and I'll be left with n plus 5. When I go over here and look at negative 9n and negative 45, I can say, oh, well, there's a 9 common in both terms, so I'm going to take a 9 out. That would leave me with negative n and negative 5. Now, there's a problem here. We have n plus 5, and we have negative n minus 5. So these don't match up. So right now, the way that I'm doing it, it doesn't work. But I can go through, and I can erase this stuff, and go back in. I'm going to keep that n plus 5 there. Instead of 9 being what's common, I'm going to take out a negative 9. And that will then leave me with n plus 5. And that's good because now this is the same as this, and now we could take that out and have n plus 5 and be left with n squared minus 9. I get the n squared from here, I get the minus 9 from here. Now with this one, n plus 5 is our linear term, but n squared minus 9, that's a difference of perfect squares. So I can then just rewrite it as n plus 5, and then from perfect squares, we can say n plus 3, n minus 3. And now I have 3 linear terms, and that is factored completely. All right, let's do 2 more examples. Whoops. Our next example says 3m cubed minus m squared plus 9m minus 3. So when I look at these 2 terms and these 2 terms, what's common in these first 2 terms? M squared. And that will leave me with 3m minus 1. What's common between 9m and negative 3? Well, 3 is common, so I'm going to take a 3 out, and that's going to leave me with 3m minus 1. Again, 3m minus 1, 3m minus 1, those are common in both, so let's rewrite that, the common factor. And then we got m squared left over, we got plus 3 left over, so I'm going to put that in the next set of parentheses, m squared plus 3. That is my final answer. Finish this while I can do this. All right, last problem here. We're going to group these 2 and group these 2. Well, what's common between 4c to the third and 8c squared? Well, 4c squared, of course. That would leave me with c plus 2. What's common between negative 9c and negative 18? Well, negative 9, leaving me with c plus 2. Again, this works out really well because c plus 2 and c plus 2 are common. If they weren't common, we try and make this maybe a positive 9 and make it work. But in this case, it is the same. So we're going to say c plus 2. That's our common factor in those. And what am I left with? I'm left with 4c squared. I'm left with negative 9 from right there. Now 4c squared and negative 9, well 4c squared is a perfect square, 9 is a perfect square, and so what I can do is I can do sum or difference of perfect squares, which is 2c plus 3 and 2c minus 3. And those are how we factor cubic polynomials by grouping. So enjoy.